Apollo 15's return plunged into chaos. A failed parachute. This major engineering disaster. Welcome to the channel. Today we explore one of history's most dramatic engineering failures. Imagine the final moments of a mission, the culmination of years of tireless effort, billions of pounds invested, and the lives of 3 astronauts hanging in the balance, hundreds of thousands of miles traveled, only for the Earth's atmosphere to present its ultimate challenge. A parachute, that deceptively simple yet utterly critical component, the last line of defense between the crew and a catastrophic impact, fails. This isn't a hypothetical scenario from a flight simulator. It is the blunt official summation of the Apollo 15 mission's re-entry in 1971, a landing with a failed parachute. Crucially, this event is unequivocally classified by the source as a major engineering disaster. The sheer weight of that designation, major engineering disaster, attached to an event that remains almost entirely undescribed in the available record, is itself a profound and unsettling revelation. How could such a critical incident, one that placed human lives in immediate jeopardy and fundamentally compromised a multi-billion-pound national endeavor at the very pinnacle of human achievement, be recorded with such stark, almost dismissive brevity? The very conciseness of its official mention, devoid of specifics regarding which parachute failed, how it failed, or the immediate operational consequences for the command module and its crew, creates an open loop of profound questions. This report, in its stark brevity, presents the most shocking detail of all. A disaster officially acknowledged, its potential for catastrophe implied, but its story largely untold, leaving us to piece together the implications of its silence for future missions and the very safety culture of space exploration. For the Apollo 15 mission in 1971, the official record states plainly, landing with a failed parachute, and classifies this as a major engineering disaster. This stark pronouncement, however, is virtually all the detail provided. There are critical aspects of any major engineering disaster that demand forensic examination: the context of the mission, any warning signs that were present, the precise mechanism of the failure, its immediate aftermath, the findings of any subsequent investigation, and its lasting legacy. We will explore each of these vital areas, attempting to understand what the official record reveals, and crucially, what it leaves unsaid. The source does not illuminate which of the multiple parachute systems, the drogue, the pilot, or the main parachutes experienced failure. It does not describe the nature of that failure, whether it was a tear, a tangle, a deployment malfunction, or a material fatigue issue. Nor does it provide any timeline of events during the critical re-entry phase, the altitude at which the failure occurred, or the precise impact it had on the command module's descent rate or trajectory. Without these foundational details, a forensic deconstruction of the event, identifying the specific sequence of failures or the engineering choices that contributed to them, becomes impossible. We are left with the profound acknowledgement of a disaster, but without the granular information necessary to understand its mechanics. This absence means we cannot establish a clear roadmap of contributing factors, specific engineering decisions, or operational procedures that might have led to such a critical incident. The basic narrative of how multiple elements might have combined to create this precarious situation remains entirely undefined beyond the initial unsettling classification. This lack of specific event data precludes any meaningful analysis of the immediate circumstances, the exact moment of failure, or the subsequent actions taken by the crew or ground control. The information necessary to answer the fundamental questions of why did this happen and how did multiple failures combine is simply not present within the provided documentation, making a detailed investigation impossible to conduct from the given source material. We can only infer the extreme operational pressure and the human stakes involved from the very term major engineering disaster. The source text offers no specifics regarding the immediate operational impact. Did the crew face an uncontrolled descent? Were emergency procedures initiated, or was the landing significantly harder or more hazardous than planned? It is a testament to the inherent risks of spaceflight that even a general statement like this carries such immense weight. Yet it leaves the investigator with no tangible threads to pull. This lack of detail prevents us from understanding the specific engineering consequences or the precise human stakes involved beyond the broad classification of a disaster. It forces us to confront the limitations of official records when critical information is absent, thereby obscuring the full story of what transpired during Apollo 15's perilous return. The Apollo 15 mission, undertaken in 1971, stands within the pantheon of human spaceflight as part of one of the most ambitious and transformative programs in history. Typically, understanding a mission's significance requires delving into its specific objectives, its scientific goals, the technological advancements it aimed to achieve, the duration of its lunar surface operations, and the overall political and public environment in which it took place. These contextual details are crucial for framing the importance of any phase of the mission, particularly a critical event like re-entry and landing, and for truly grasping the gravity of an engineering failure. However, the provided source text offers no such elaboration. It acknowledges Apollo 15 and its year, but does not detail what was being attempted beyond the general act of a landing, nor does it explain why this particular mission mattered within the broader Apollo program. The source remains silent on specific scientific instruments deployed or any new lunar roving capabilities being tested. We are not informed about the crew's names, their extensive training, the duration of their time in space, or the specific pioneering tasks they were assigned. This absence of context means that the inherent risks of spaceflight, always present, cannot be fully appreciated in relation to the mission's scope and ambition. Without understanding the specific achievements and aspirations of Apollo 15, the full weight and potential impact of a major engineering disaster involving a parachute failure cannot be adequately conveyed. The human and engineering stories behind humanity's journey beyond Earth are typically rich with such contextual layers, but this source offers none, leaving the mission's purpose and its critical importance undelineated. The source text provides no narrative to connect the potential disaster to the mission's wider objectives. It leaves us to contemplate the profound disconnect between the ambition of lunar exploration and the stark, unadorned fact of a critical failure during the journey home. This lack of detail prevents us from truly appreciating the operational pressures faced by the crew and ground control, or the engineering challenges that defined this era of spaceflight. The context that would allow us to understand the true stakes of the major engineering disaster is simply not provided, leaving us with a powerful, yet abstract, declaration of failure. This void leaves the audience unable to fully grasp the extraordinary context in which such a critical event unfolded, diminishing our ability to understand the full implications for the astronauts, the engineers, and the entire space program. The classification of the event as a major engineering disaster implies profound stakes, yet the source provides no means to articulate them beyond this bare statement. In the forensic deconstruction of any major engineering disaster, the identification of warning signs, whether dismissed reports, preceding near misses, overlooked data, or unheeded internal critiques, is absolutely paramount to understanding systemic failures. These precursors often highlight institutional blind spots, expose design flaws that were flagged but not addressed, or reveal the pressures that can compromise safety protocols in complex, high-stakes environments like human spaceflight. Such details are crucial for understanding the wider institutional and engineering context that allowed a failure to manifest. However, the provided source text for the Apollo 15 landing with a failed parachute in 1971 offers no information whatsoever regarding any such warning signs. It does not mention any prior incidents involving parachute systems, either on previous Apollo missions or during ground testing. There is no reference to any technical reports, internal memos, or expert opinions that might have flagged potential vulnerabilities in the design, manufacturing, or operational procedures of the parachute system. The source provides no indication of any internal debates, dissenting voices from engineers, or overlooked data points that, in hindsight, could have foretold this major engineering disaster. Without this crucial context, it is impossible to assess whether the parachute failure was an isolated, unpredictable incident, a rare anomaly, or the culmination of systemic issues that had been brewing within the program for some time. We cannot determine if the failure was a black swan event or a predictable consequence of known but unaddressed deficiencies. The source provides no details to suggest that anyone knew of a potential problem beforehand, or that any warnings were tragically ignored by program management under schedule or cost pressures. This absence prevents any analysis of the decision-making processes, the rigor of risk assessments, or the adequacy of safety protocols that were in place leading up to the mission. Were there any previous anomalies that, in hindsight, should have been interpreted as critical indicators of a potential catastrophic failure? The source does not furnish us with the evidence to answer such vital questions, leaving this aspect of the disaster completely unaddressed. This lack of information is not merely an omission. It fundamentally limits our ability to understand the institutional behavior and engineering culture that underpinned the Apollo program at the time, and to identify opportunities that might have existed to prevent such a hazardous outcome. Without insight into potential warning signs, it becomes impossible to truly grasp the preventative measures that could have been implemented, or to critique the decision-making framework that allowed the mission to proceed with a potentially vulnerable system. This silence on precursors is a significant gap in any comprehensive understanding of an engineering failure of this magnitude, leaving a critical piece of the puzzle missing for future analysis. The core of any engineering disaster investigation lies in meticulously detailing the moment of failure and its immediate sequence, explaining not just that something broke, but forensically why it was allowed to break. This involves understanding the specific components involved, the materials used, the environmental forces at play, and the exact mechanism of the failure. For a parachute system, this could mean analyzing fabric tear propagation, stitching integrity, deployment sequence timing, pyrotechnic charges, or the aerodynamic loads experienced during high-speed atmospheric re-entry. However, the provided source text, while stating that Apollo 15 experienced a landing with a failed parachute in 1971 and classifying it as a major engineering disaster, offers no specific details regarding the failure itself. It does not identify which of the spacecraft's parachutes failed. Was it a drogue parachute designed to stabilize the command module at high altitude, a pilot parachute used to extract the main parachutes, or one of the three colossal main parachutes responsible for the final controlled descent? The source provides no description of the failure mechanism. Was it a tear, a tangle, a deployment malfunction, or a material failure from a manufacturing defect or degradation? Critically, the source also does not explain the immediate operational implications of this failure for the crew or the command module during its descent. Without this essential information, it is impossible to reconstruct the precise events leading to the critical moment, to understand the physics of the malfunction, or to assess the severity of the situation from an engineering perspective. The source does not specify the design specifications of the parachute system, the materials used in its construction, or the testing protocols that were in place to ensure its reliability. Therefore, any discussion of why the failure occurred, or the specific engineering contexts such as cost pressures, weight reduction requirements, or schedule urgency that might have influenced its design or maintenance, cannot be drawn from the provided text. The critical insights into the technical breakdown, which are fundamental to understanding an engineering disaster and preventing its recurrence, are completely absent. This silence means we cannot even begin to ask the crucial questions about the specific design choices made at the time, what trade-offs were accepted, or what was known and unknown about the parachute's behavior under actual re-entry conditions. The details that would allow us to avoid hindsight bias and understand the decision-making as it appeared to engineers before the event are simply not available. This fundamental lack of technical detail prevents any meaningful forensic analysis, leaving the precise how and why of this major engineering disaster entirely in the realm of conjecture rather than documented fact. The audience is left without the specifics to understand the true engineering vulnerabilities that manifested during this critical phase of the mission. If this exploration of the unknown has piqued your curiosity, subscribe now to ensure you don't miss our deep dives into the untold stories of space exploration. Following an event designated as a major engineering disaster, the aftermath typically involves profound and far-reaching consequences, human, institutional, and program-wide. This often includes immediate crew reactions and health checks, post-landing procedures for spacecraft inspection, changes in mission protocols, and a thorough reevaluation of safety standards across the entire program. Understanding these immediate effects is crucial to comprehending the true cost of the disaster. However, the provided source text for the Apollo 15 landing with a failed parachute in 1971 offers no specific details regarding the aftermath of this incident. It does not describe the immediate impact on the crew, whether they were injured, if their lives were significantly endangered beyond the inherent risk of a failed parachute, or how they psychologically coped with the perilous descent. There is no information about the condition of the command module after landing, or if the failure necessitated emergency recovery procedures from the naval forces awaiting them. The source also does not detail any institutional responses, such as immediate internal investigations, urgent technical reviews, or public press conferences that would typically follow an event of this magnitude. Furthermore, it provides no insight into how this major engineering disaster affected the morale of the program's thousands of engineers and technicians, the public's perception of spaceflight safety, or the schedules and budgets of subsequent Apollo missions. Without these specifics, it is impossible to gauge the true human cost, the operational pressure faced by mission control, or the broader engineering consequences that stemmed from the parachute failure. The absence of such critical information prevents any assessment of how the event was managed, mitigated, or communicated within NASA and to the wider world. The source offers no answers to these crucial questions, leaving the immediate and short-term aftermath of the disaster entirely unelaborated. This void of information restricts our ability to contextualize the event within the broader narrative of the Apollo program and its meticulous approach to safety and risk management. It leaves us to speculate on the quiet yet profound ripple effects such a major engineering disaster would undoubtedly have had on the people and the program involved. The lack of documented aftermath prevents us from understanding the immediate operational response, the extent of the danger averted or endured, and the initial institutional reckoning with a critical system failure during a high-profile mission. A thorough investigation into any engineering disaster is designed to uncover systemic causes, to understand how multiple independent failures might have combined, who possessed critical knowledge, and when. This forensic approach aims to identify any concealed or understated issues that contributed to the event, moving beyond immediate technical failures to address institutional shortcomings, cultural factors, and decision-making processes. However, the provided source text for the Apollo 15 landing with a failed parachute in 1971, while categorizing it unequivocally as a major engineering disaster, offers no specific details regarding any subsequent investigation or its findings. It does not mention whether an official board of inquiry was convened, what methodologies were employed to analyze the failure, or what conclusions were ultimately drawn regarding the root causes. The source provides no information on whether the failure was attributed to design flaws in the parachute system, manufacturing defects in its construction, material fatigue from space exposure, human error during packing or deployment, or operational oversight by ground control. Crucially, it does not detail any systemic issues that were identified across the program, nor does it shed light on who within the organization might have known about potential vulnerabilities and when. There is no mention of any internal reports, technical analyses, or recommendations that emerge from such an investigation, which would typically form the bedrock of future safety improvements. Without these findings, it is impossible to understand the institutional context that permitted the failure, to identify any areas of negligence or oversight, or to assess the robustness of NASA's safety culture at the time. The critical insights into accountability, responsibility, and the broader organizational factors that contribute to such disasters are completely absent from this record. The source text provides no answers, leaving these vital questions unanswered. This silence prevents any analysis of the institutional learning process, the evolution of engineering standards, or the reinforcement of safety protocols that are the hallmarks of a resilient space program. The lack of documented findings means that the opportunity to understand and prevent similar future incidents, which is the primary purpose of any post-disaster investigation, remains unfulfilled within the confines of this official record. It leaves a critical void in our understanding of how NASA addressed a major safety incident and what specific steps were taken, if any, to prevent its recurrence in subsequent missions. The legacy of any major spaceflight incident is typically defined by the profound changes it instigates, the enduring lessons it imparts for future missions, and its lasting impact on those who follow in the footsteps of the pioneers. Disasters often serve as powerful catalysts for reevaluating design philosophies, overhauling operational procedures, and fundamentally reshaping safety cultures, all with the paramount goal of ensuring that similar failures are not repeated. Such events become touchstones, referenced for decades in engineering handbooks and astronaut training manuals, shaping the very future of human spaceflight. However, the provided source text for the Apollo 15 landing with a failed parachute in 1971, which is described as a major engineering disaster, offers no specific details regarding its legacy. It does not outline any specific changes that were implemented within the Apollo program or subsequent spaceflight endeavors as a direct result of this parachute failure. There is no mention of revised parachute designs for later Apollo missions, enhanced testing protocols for re-entry systems, or altered re-entry procedures that might have been adopted to prevent a recurrence. The source also provides no insight into how this event influenced the training of future astronauts, the decision-making of mission controllers during critical phases of flight, or the overall approach to risk management in human spaceflight. Without this information, it is impossible to determine what, if anything, truly changed as a consequence of this incident, or what it meant for the people who dedicated their lives to space exploration. The enduring lessons, the shifts in engineering paradigms, and the enhanced safety measures that typically emerge from such events are entirely absent from the provided documentation. The source does not provide the details to answer critical questions, leaving its legacy undefined and its potential lessons unarticulated within this record. This absence is particularly striking, given the classification of the event as a major engineering disaster, a term that inherently suggests a significant impact and subsequent corrective action. The silence on legacy means that the full historical and developmental significance of the Apollo 15 parachute failure cannot be ascertained from this official account, leaving a crucial gap in our understanding of how spaceflight safety evolved. It leaves us to ponder what lessons were truly learned, or perhaps, tragically, what opportunities for learning were lost due to the lack of detailed public record. The Apollo 15 mission in 1971 is officially recorded as having experienced a landing with a failed parachute, an event unequivocally labeled a major engineering disaster. Yet, what truly remains from this official account is not a detailed narrative of engineering failure, human resilience, or systemic reform, but rather a profound and unsettling absence of specific information. The source text, while identifying a critical incident of immense gravity, provides no specifics on the failure mechanism, the immediate consequences for the crew, the findings of any subsequent investigation, or the lasting legacy for spaceflight design and safety. This pervasive lack of detail prevents any forensic deconstruction of the event, leaving us unable to draw specific lessons, understand the complex interplay of factors that led to the failure, or even fully appreciate the operational implications of what occurred during that critical descent. The human and engineering stories, the operational pressures endured, and the complex chain of decisions and consequences that define such moments in history are entirely unelaborated. We are left with a stark official classification, but without the narrative depth, the technical specifics, or the institutional context that would allow for a deeper understanding of this major engineering disaster. This enigmatic entry in the historical record serves as a potent reminder of the inherent dangers of spaceflight, where even the most fundamental systems can fail, and the profound importance of meticulous documentation in learning from every challenge. It compels us to consider the stories that remain untold, the lessons that might have been learned, and the potential impact of information that is not fully brought to light. The very act of acknowledging a major engineering disaster without providing the accompanying details leaves a significant void in our historical understanding of spaceflight safety. What enduring implications does such an undocumented major engineering disaster hold for our understanding of risk, transparency, and accountability in the continued pursuit of humanity's journey beyond Earth? Share your thoughts in the comments below. Thanks for watching. If you enjoyed this, please like and subscribe for more engineering history.